Welcome to our demo of ERP Next, a comprehensive enterprise resource planning solution built to streamline and simplify everyday business operations. Here, we showcase PlasticPack Industries, a fully configured demo environment that simulates the end-to-end workflows of a plastic manufacturing enterprise. PlasticPack Industries represents a complete ERP setup for plastic injection molding operations. In this demo scenario, the company is assumed to produce 50,000 units per day across 11 molding machines, manufacturing shampoo bottles, caps, and cosmetic jars for FMCG clients, along with pharma vials, dropper assemblies, and child-resistant caps for pharmaceutical customers. What you're about to see is a complete business cycle, from a customer order, through raw material procurement, production with real-time rejection tracking, quality inspection, and delivery. Every step linked end-to-end. Let me start with a quick look at the system setup. This is plasticpack.bharatclouds.com, PlasticPack Industries ERP system, hosted on the cloud. Accessible from any browser, any device, the production manager can check work order status from his phone on the shop floor. The purchase head can approve POS from home, and the MD can review dashboards from anywhere.
This is the home workspace, the first screen every user sees after login. On the left, you have the sidebar. This is your navigation panel with all the modules: home, accounting, buying, manufacturing, shop floor, stock, selling, quality, and more. Each of these is a workspace, a dedicated area for a specific business function. In the center, you see shortcuts and quick actions relevant to your role. At the top right, you have notifications. The bell icon shows pending approvals, workflow alerts, and system notifications. If a purchase receipt is waiting for quality inspection approval, the QC manager sees it here immediately. No emails to chase, no papers to sign, everything flows through the system. Now, this search bar at the top, in ERP Next, we call it the awesome bar, and it truly is awesome. This is the fastest way to navigate the entire system. You don't need to remember menu paths or click through multiple screens. Let me show you what I mean. If you know a document number, just type it directly. The system opens it instantly. No need to go to selling, then sales order, then search. One step, or type a module like purchase order directly to list all the purchase orders. It's a universal search across every document in the system. The awesome bar searches across items, customers, suppliers, documents, reports, and even settings. It's like having Google for your entire business. Everything is one search away. Next to the search bar, you'll notice the help section. This is built into every screen in the system. If a new user is creating a purchase order for the first time and isn't sure what a field means, they can click the help icon right on that field and get a contextual explanation. No need to call IT or read a manual. ERP Next also has complete documentation accessible from here, setup guides, workflow explanations, and video tutorials. For PlasticPack, we've also configured custom tooltips on fields that are specific to plastic manufacturing. The goal is that after initial training, the system should be self-explanatory. The help is always right there where you need it. Role-based access control. Right now, I'm logged in as administrator, so I can see everything. All workspaces, all modules, all data. But in a real production environment, every user sees only what they need to see. This is controlled by roles and permissions. A sales manager at PlasticPack would log in and see the selling workspace, sales orders, quotations, customer records, and sales reports. They can create new quotations, check order status, and see delivery timelines. But they cannot see the manufacturing workspace, they cannot see purchase prices, and they cannot access accounting entries. Their view of the system is limited to exactly what their job requires. Same for the production supervisor, the purchase manager, the quality inspector, and the storekeeper. And the MD or director? They see the dashboards and reports across all modules, revenue, production output, quality metrics, stock levels, without needing to open individual transactions. A bird's eye view of the entire business. This role-based access does three things. First, it simplifies the interface. Every user sees a clean, uncluttered screen with only the options relevant to their job. No confusion, no overwhelm. Second, it enforces data security. Sensitive information like pricing, costs, and margins is visible only to authorized roles. And third, it creates accountability. Every action is logged against the user who performed it. You know exactly who approved that purchase order, who rejected that quality inspection, and who completed that job card. The system supports unlimited users. You can have 10 operators on the shop floor, each logging their own job cards on tablets, simultaneously with the purchase team processing receipts and the accounts team reconciling invoices. Everyone works in their own workspace, on their own data, without stepping on each other. Now that you've seen how the system is organized, let me walk you through the master data, the foundation on which all transactions run. We'll look at items, BOMs, warehouses, and workstations, the building blocks of PlasticPack's manufacturing process. PlasticPack serves 5 customers, 3 FMCG companies including Surian Consumer Care, Velvet Cosmetics and Annapurna Foods and Beverages. Plus 2 pharma companies, Medalex Pharma and Curvera Labs. On the supply side, raw material comes from Reliance Polymers, Indian Oil Petrochemicals, and specialist masterbatch and additive suppliers. Before we look at individual items, let me show you how everything is organized. In ERP Next, items are classified into item groups. Think of it as your product catalog structure. At the top level, we have 3 main categories: raw material, products, and packing material. Under raw material, you'll see polymer resins, masterbatch, and additives. These are the inputs to our molding process. Under products, we have containers and bottles, caps and closures, and pharma packaging. These are what we sell. This hierarchy matters because it drives defaults throughout the system. When you create a new PP resin item and put it under polymer resins, it automatically inherits the right warehouse, the right expense account, the right valuation method. Your team doesn't have to configure each item from scratch. It also powers your reporting. You can instantly pull up all raw material consumption, or see revenue by product category, because the grouping is built into every transaction. Now let me show you the actual items within these groups. Item Master. PlasticPack manages 27 items, 10 raw materials including PP, HDPE, PET resins, 4 types of color masterbatch, UV stabilizers and anti-static additives. Then 13 finished goods across FMCG and pharma packaging, plus packing materials. Each product has a bill of materials. Here's the BOM for a 500 ml shampoo bottle, 25 grams of PP homopolymer plus 1 gram of white masterbatch per piece. The molding operation is linked to our injection molding machine workstation type, with a cycle time of 0.075 minutes per piece. That's a 4-cavity mold producing about 800 pieces per hour. Machines and molds. We have 11 injection molding machines ranging from 80-ton presses for small caps up to 450-ton machines for large containers like 1-liter oil bottles. Each machine has its hourly operating cost broken down into electricity, labor, rent, and consumables, which flows directly into product costing. Now let me show you what really sets this system apart for injection molders, the Mold Master. If you're in this industry, you know the mold is your most expensive asset. A single mold can cost 5 to 50 lakhs. It determines your product quality, your cycle time, your rejection rate, and most factories track all of this in Excel or in someone's head. That ends here. PlasticPack has 25 molds. At a glance, I can see every mold, which product it makes, which customer it belongs to, how many cavities it has, and whether it's active, under maintenance, or retired. Let's open this one, MLD008, a 4-cavity mold for 500 ml shampoo bottles. Look at what's captured here. First, the product link. This mold is tied to item FGSB 500 ml. So when a work order comes in for shampoo bottles, the system knows exactly which molds can produce it. Next, the customer link. This mold belongs to Surian Consumer Care. In injection molding, customers often own the molds but leave them at your factory. You need to know whose mold is whose, especially when a customer asks, "Where is my mold right now?" You can answer that in 2 seconds. Then the cavity details. Total cavities is 4, running cavities is 4. Today all 4 are running. But here's where it gets real. Suppose cavity number 3 gets damaged. The ejector pin breaks, there's a crack. Your tool room updates running cavities from 4 to 3. Immediately, the system knows your output per cycle just dropped by 25%. Your production planning adjusts. Your NOK rejection analysis knows to expect different numbers. And the current location. Right now this mold is in mold store. When it gets picked up and mounted on IMM06, The tool travel card tracks that movement, pickup time, machine assignment, mold change duration, first piece inspection before production starts. And the mold's age matters too. This one was made in 2022. A 4-year-old mold behaves differently from a brand new one. Flash increases, dimensions start drifting, cycle times may need adjusting. Having the age right here, alongside the rejection history from the NOK logs, tells your tool room exactly when a mold needs preventive maintenance, not after it starts producing defective parts, but before. 25 molds, every one tracked. For a factory running 10 to 12 machines with molds going on and off the floor every day, this is the difference between knowing what's happening and guessing. Shift register. The factory runs 2 shifts, 6 a.m. to 2 p.m., and 2 p.m. to 10 p.m. Rejection tracking. Rejection tracking uses 10 predefined defect categories specific to injection molding, short fill, flash, burn mark, sink mark, warpage, and others. Each defect is classified by group, visual, dimensional, material, or process, which drives your root cause analysis.
Now that you've seen how the system is set up, the items, the bombs, the machines, the molds, let me walk you through what happens every day. A real business cycle, from the moment a customer places an order to the moment the goods leave your factory gate. Everything you're about to see is connected. One document leads to the next, no data re-entry, no gaps. Sales order. Customer. Surian Consumer Care, one of our FMCG clients, needs 10,000 shampoo bottles and 10,000 matching flip-top caps. Their purchase order comes in, and our sales team creates a sales order. Look at what's captured here: customer name, 2 line items, quantities, rates, and most importantly the delivery date. This order is worth 73,000 rupees, 55,000 for the bottles at 5.50 each, and 18,000 for the caps at 1.80 each. Now here's what happens the moment this sales order is submitted. The system knows we need to manufacture 10,000 of FGSB 500 ml and 10,000 of FGSC 28 mm. It knows the BOM for each. It knows the raw materials required. It knows which machines can run these molds. From this single document, we'll create work orders, calculate raw material requirements, raise purchase orders, track production, inspect quality, and deliver. One entry point, everything flows downstream. Notice the status. It shows, to bill. That means delivery is complete, but we haven't invoiced the customer yet. ERP next tracks these separately. Your dispatch team sees, delivered. Your accounts team sees, not yet billed. Everyone knows exactly where things stand without asking each other. Purchase order and receipt. Before we can produce anything, we need raw material. The system tells us exactly how much. For 10,000 bottles, the BOM says 25 grams of PP per piece. That's 250 kilos of PP homopolymer. For the 10,000 caps, 4 grams of PP copolymer each. That's 40 kilos. Plus white masterbatch for the color loading on both products. So our purchase order goes to Reliance Polymers, 300 kilos of PP high, 50 kilos of PPCP, and 10 kilos of white masterbatch. We've ordered buffer on the resins for trial shots, regrind, and normal process waste, and the masterbatch quantity accounts for the fact that we already had some in stock from the previous batch. Every injection molder knows you never order purely off the BOM. You check what's on the shelf first. Total PO value, 42,700 rupees. Delivery scheduled in 2 days. 2 days later, the truck arrives. Our stores team creates a purchase receipt against this PO. Notice how the items, quantities, and rates automatically pull from the purchase order. No retyping. But look at the warehouse assignments. This is where our warehouse structure pays off. PP granules go into the plastic granules warehouse. Masterbatch goes into the masterbatch warehouse. Not everything dumped into one generic stores. Each material has its home. The moment this receipt is submitted, 3 things happen simultaneously. 1. Stock levels update in real time. 2. The purchase order status changes to received. 3. The accounting entry is posted. Stock received but not billed gets debited. The supplier's account gets credited. Stores, purchase, and accounts, all updated from one document. Work order and job cards. Now we have material in stock. Time to manufacture. 2 work orders are created from the sales order, one for bottles, one for caps. Let's look at the bottle work order. 10,000 pieces of FGSB 500 ml. Notice what the system has automatically pulled in: the default BOM, the WIP warehouse where materials will be consumed, the finished goods warehouse where output will land, and the link back to the original sales order. Your production team doesn't set any of this up. It flows from the BOM and the company defaults. The planned start date is 2 days before delivery, giving us time for production, quality checks, and packing. Now when I submitted this work order, something important happened behind the scenes. The system created a job card automatically. The job card is where the shop floor lives. This is what your operator or supervisor actually works with. It tells them, you're running the molding operation for 10,000 shampoo bottles on IMM06, our 250-ton press. The workstation type is injection molding machine. And here's the time log. Production started at 6 a.m., shift 1. The operator records when they started, when they finished, and how many pieces they completed. 10,000 pieces, shift ends at 2 p.m. 8 hours of production. In a real scenario, your supervisor might split this across multiple shifts. 5,000 in shift 1, 5,000 in shift 2. Each time log entry captures the window separately. So at the end of the day, production managers know exactly how many pieces came off which machine in which shift. When this job card is submitted as complete, the work order knows the operation is done. Now we just need to do the material accounting. Material flow. Stock entry. This is the part most people find confusing at first, but once you see it, it's beautifully simple. Manufacturing in ERP next involves 2 stock entries. The first one, material transfer for manufacture. Before production starts, raw materials need to move from storage to the shop floor. This entry takes 250 kilos of PP homopolymer from the plastic granules warehouse and 6 kilos of white masterbatch from the masterbatch warehouse, and moves them both into the work-in-progress warehouse. Why not consume them directly? Because in reality, your materials sit on the shop floor for hours, maybe days. They're not in stores anymore, but they're not finished goods yet either. WIP captures that in-between state. Your stores team knows the material has left. Your production team knows it's on the floor. Your accounts know exactly where the value sits. Notice this is linked to the work order, so you know exactly which production run consumed which materials. The second entry, manufacture. This is where the magic happens. One transaction does 2 things. It consumes the raw materials from WIP, 250 kilos of PP, 6 kilos of masterbatch. Gone from WIP. And simultaneously, it creates 10,000 finished shampoo bottles in the FMCG warehouse. Raw material goes down, finished goods come up. The BOM costs flow through, so each bottle now carries its material cost, its machine cost from the operation time, everything. When this is submitted, the work order status changes to completed. If you go back to the sales order, it now knows that manufacturing is done and the goods are ready to ship. 2 stock entries, one moves materials in, one converts them to finished goods. That's the entire manufacturing accounting in ERP next. Not OK, also known as NOK Rejection Tracking. Now we come to the feature that every injection molder asks about, and that no generic ERP provides. While those 10,000 bottles were being produced, your shop floor didn't just count pieces. They tracked quality in real time. This is the not OK or NOK rejection log. Let's read this document like your production manager would on a Monday morning. Date, yesterday. Shift I machine, IMM06, the 250-ton press. Mold, our 4-cavity shampoo bottle mold. Material, PP homopolymer. Customer, Surrey Consumer Care. Everything linked. Total produced in this shift, 5,200 pieces. OK pieces, 5,070. Not OK or NOK, 130. That's a 2.5% rejection rate. Now a generic ERP would stop here. 130 rejected. Done. But for an injection molder, that number means nothing without the defect breakdown. Here's the breakdown. 45 pieces with short fill. That's your number one defect this shift. Short fill means the molten plastic didn't completely fill the cavity. Why? Could be low injection pressure, could be melt temperature too low, could be a blocked gate. Your quality team now knows exactly where to investigate. 35 with flash. That's excess material squeezing out at the parting line. Clamp force might be insufficient, or the mold faces might need repolishing. 20 burn marks. Trapped air isn't venting fast enough, or the material is degrading from too high temperature. 10 color changes. Probably from the previous batch's pigment still in the barrel during changeover. 15 damaged. Handling issues after ejection. 5 foreign material. Contamination in the hopper or the regrind mix. Each of these tells a different story. Each points to a different root cause. And the system has them all, shift by shift, machine by machine, mold by mold. But it goes even deeper. Scroll down to the process parameters. Zone 1 temperature, 210 degrees. Zone 2 to 215. Zone 3 to 220. Zone 4 to 205. Injection pressure, 85 bars. Flow rate, 45. Cooling time, 12 seconds. Cycle time, 18 seconds. When your quality manager sees 45 short fills and then checks Zone 4 was only 205 degrees while Zone 3 was 220. That 15-degree drop near the nozzle could be exactly why the material wasn't flowing fully into the cavity. The data tells the story. And no one had to write this in a register or transfer it from a paper form. The operator entered it at the machine, during the shift, in real time. One last thing. Look at the hourly breakdown. Production isn't tracked as one 8-hour block. It's broken into 2-hour intervals. 6 a.m. to 8 a.m., 1,280 produced, 25 rejected. 8 a.m. to 10 a.m., 1,320 produced, 35 rejected. 10 to 12, 1,300 produced, 35 rejected. 12 to 2 p.m., 1,300 produced, 35 rejected. See how rejection was lower in the first 2 hours and higher afterwards. Maybe the machine was running perfectly at startup, but by mid-shift the barrel temperature drifted, or the cooling water temperature rose. This interval tracking lets you pinpoint exactly when quality started slipping, not just that it slipped. Tool or mold travel card. Every time a mold is picked up from the store and mounted on a machine, this card tracks the entire journey. Let me show you. 5:15 a.m. Mold MLD008, our 4-cavity shampoo bottle mold, is picked up from the mold store. 5:20, mold change starts on IMM06. 5:45, mounted and ready. That's a 25-minute changeover, and now management knows exactly how long mold changes take. If one team does it in 25 minutes and another takes 45, that's a training opportunity, not a mystery. Before production starts, 3 checks happen right here in the system. First, machine condition check. Tie bar alignment, clamp force, ejector stroke, nozzle seating, hydraulic pressure, cooling water flow, 6 parameters, all verified OK. This ensures the machine is ready for this specific mold. Second, process parameter verification. All 8 settings confirmed: zone temperatures, injection pressure, speed, cooling time, cycle time. And here's something interesting. Notice zone 4 is recorded at 205 degrees. Later in the NOK log, that same reading shows up as the root cause for short fill defects. The data connects. Third, first piece inspection. Before running full production, the first piece from each cavity is measured. Weight, height, neck diameter, wall thickness, visual checks, across all 4 cavities. All pass. Now production is approved to run. 2:30 p.m., shift ends, mold is dropped. This single document answers every question management asks. When was the mold mounted? Who approved it? Were the parameters checked? Did the first piece pass? How long was the changeover? And it's all linked back to the NOK rejection log and the work order. No paper forms. No missing records. No arguments about whether the process was followed. Quality inspection. After production, before the goods leave your factory, they go through a formal quality inspection. A sample of 50 pieces pulled from the batch. 6 parameters tested. Weight, 25.2 grams, specification says 24 to 26. Pass. Height, 165 mm, spec says 164 to 166. Pass. Neck diameter, 28.1 mm, spec says 27.8 to 28.3. Pass. This one matters because the cap has to fit perfectly. Wall thickness, 0.82 mm, spec says 0.75 to 0.90. Pass. Visual appearance, no defects observed. Pass. Drop test from 1.2 meters, no crack. Pass. Status, accepted. These bottles are cleared for shipping. If any parameter had failed, the status would show rejected, and the system can block the delivery note until the quality issue is resolved. No shipping defective goods to the customer. Delivery. The final step. Everything is produced, everything is inspected, everything is approved. Time to ship. The delivery note for Surian Consumer Care, 10,000 shampoo bottles and 10,000 caps. When this delivery note is submitted, finished goods stock decreases by 10,000 bottles and 10,000 caps from the FMCG warehouse. The sales order status updates to completed. If you have logistics integration, this is where the transporter gets notified.
That's PlasticPack Industries, a complete ERP system purpose-built for plastic injection molding. From the customer order through procurement, production with real-time cavity-level rejection tracking, quality inspection, and delivery. What you've seen isn't a mock-up. This is a live system with real transactional data flowing through standard ERP Next plus our custom manufacturing module built specifically for injection molding operations. Every number you saw, the 2.5% rejection rate, the 45 short fill pieces, the zone temperatures, that's the kind of visibility that helps you reduce scrap, improve mold life, and deliver on time. We'd love to walk you through how this would work for your specific setup. Thank you.